Let's begin. Today's January 12th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 1, 6, 9, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine compares it to the number 1. So should the value of triangle be equal to 1, or should it be greater than 1? Criteria card B will take a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know if the sum total is an even quantity or an odd quantity. Criteria card E will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will take a look at the 3-digit solution and will let us know a little bit about its structure. One of the possibilities is that the 3-digit code has no repetitions, as in the example 125, or it could be a double number, as in the example 112, or it could be a triple number, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. The first thing I'm going to test is criteria card B. Okay, so the Turing Machine does not approve of my choice in square. I did pick an odd 1, but since the Turing Machine does not agree with it, it's informing us that square should actually be even. So let's go ahead and type that up in our notes in section B. And we'll just state that square is an even digit. And since it is even, let's go ahead and cross out the 3 odds. Okay. The next thing I think I'd like to test is criteria card D. Okay, so in criteria card D, we are adding up the 3 digits. Let's go ahead and do that with the proposal. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, and the Turing Machine agrees with that. So yes, the sum of the 3 digits should actually be even. So let's go ahead and type that up in our notes in section D. And we'll say that triangle plus square plus circle should be even. Now, what can we say? Well, since we've already established that square is even, if we want the overall sum to remain even, there are 2 possibilities. One of them is that, we're dealing with an all-even solution. The other is that both triangle and circle would have to be odd. Now, the reason that is true is that when you add up those 2 odd digits, that sum is actually even. And then when we add the middle even digit, the sum remains even. So we're looking at potentially an all-even solution or an odd, even, odd solution. Okay, and so let's see. Let's go ahead and test criteria card E. Okay, so the Turing Machine also agrees. So in criteria card E, we are adding the first two digits. So 3 plus 1 is 4. 4 is less than 6. And since the Turing Machine agrees with the proposal, it is true that the sum of the first two digits should be less than 6. So let's go ahead and type that up in our notes. And that's in section E. And we'll state that triangle plus square should be less than 6. And what can we say about that? Well, if we want the sum of the first two digits to be less than 6, I don't think triangle can be a 5. Because when you add 5 to the smallest of 2, that's still larger than 6. And I think by that same reasoning, I don't think triangle could be 4 either, because 4 plus 2 is 6, and that's still too large. So we can cross out the 4. Now the 3 is okay, because you can always add 3 and 2. That's a 5. And we can't cross out the 4 because you could add it to a 1. So that 1, 4 is 5. Obviously, 4 does not work with either 2 or 3, but it's still, possible. Let's see, anything else? I think that does it. Well, yeah, this does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that first digit to the number 1. At this point, it's either a 1 or a 2 or 3. We also did not query criteria card C, finding out how many 3s there are. And then we also did not test criteria card F, seeing a little bit about the structure, whether there's any duplicate digits or if they're all unique. So let's see, what can we say? Well, as far as 3s go, we know you can't have 3 3s since, that middle digit is even. And the 2 3s in triangle and triangle and circle are still available. What about criteria card A? Well, if it is to be a 1, then that would mean that that forces square to be a 4. Now at that point, I guess you could still, let's see, if it is odd, remember that circle then has to be an odd. Now the question is, could it be 1 4 1, 1 4 3, 1 4 5? Yeah, because we do have criteria cards C and F that will inform us, are they all unique? And how many 3s are there? If I had to guess, I would probably say that they're going to be unique, but it's just a hunch at this point, and that then it becomes a toss-up. Maybe there is a 3, maybe there isn't. Trying to see if there's anything else. Yeah, we weren't able to cross out anything in circle. And honestly, the only sort of reference is criteria card D. And all that tells us is that, it's got to somewhat match the type of what triangle is. So somehow we have to force both of them in some sense. And the only way to force triangle is to actually, pick one. Because if we have 2 and 3, well, we do have options. Let's see. If it is an all-even solution, what would we say about that? Well, an all-even solution would not be unique. Something had to be, doubled up or even be a triple number. But it can't be well, okay, let's say this. It can't be a triple number because well, that's not true. Let's see. Could I have a triple number? I'm trying to see if I can somehow make a contradiction. If I have a triple number, doesn't necessarily mean that they're all even or all odd. Oh, let's see. Yeah, I'm not sure at this point now. I mean, we know there can be 3 3s because, again, we have square as even. So you could have 2, 1, or none. If you had a triple number, yeah, maybe you could, well, yeah, I kind of take that back because part of the argument is it's already gameplay. You already know that's even. But if you're just looking at the criteria cards, I don't know if I can make an argument one way or the other. So let's see. If square is 4, that forces triangle to be a 1. And then either there is a 3 or there's not. And there probably aren't duplicates. But if square is 2, yeah, maybe square can't be 2 because there'd be just too many possibilities. I don't know. 1, 2, 1. 1, 2, 3, 1, 2, 5. Yeah, I'm not sure. Well, let's go ahead. I'm just going to go with the easiest possibility, and we'll say 1, 4, and I'm going to say there are no 3s. So 1, 4, 5. So let's see where that takes us. But just to double check, is that middle digit even? It is. The sum is even. Yes, it's 10, and the sum of the first 2 is less than 6. All right. Well, I guess let's go ahead and test criteria card A. Okay, so it is not true that triangle is 1. The Turing machine does not agree with that. So let's go ahead and cross out the 1. And then we'll type up the notes that says that triangle should actually be greater than 1. Okay, so triangle should be greater than 1. And let's see. So since triangle has to be greater, now we can actually cross out the 4 in square because 4 added to even the smallest of 2 is already 6. So yeah, we can eliminate the 4. And so now the question is, do we have duplicates? How many 3s are there? So we're looking at 2, 2. Yeah, I guess you could have 2, 2, 2. Yeah, you could have, I don't think it would be, let's see, could you have a pair of 2s? Yeah, I guess you could have 2. Well, remember, they've got to match up. So it would be, if there would be a 2 in triangle, there would have to be a 2 or 4 in circle. So yeah, so it'd have to be 2, 2, 2 or 2, 2, 4. And then if it were a 3, again, it would have to match up being odd in circle. So 3, 2, 1, 323, 325. Yeah, there's just too many possibilities. We need to whittle it down. So let's go ahead and test criteria card F. Okay, so it does not like the fact that we have all unique digits. It doesn't like the fact that there are no repetitions. So either you have a double number or a triple number. Okay, so that's still sort of outstanding. So we'll just say that the solution is a double or triple number. And I'm not sure, I don't think I made a good enough argument stating whether we could or could not have a triple. Yeah. Okay. Well, let's keep going. I don't think we can cross out. Let's see. Can we cross out anything? No. Okay. Well, let's go ahead and test criteria card C. Okay, finally, something breaking our way. So notice that in my proposal, I don't have any threes. So the Turing Machine agrees that there should be 0 threes. So let's go ahead and type that up. So that's extremely helpful. So we'll state that the solution has no 3-digit. Okay, so okay, good. So yeah, let's go ahead and cross out that 3 in triangle and that 3 in circle, which leaves us an even in triangle. So that means we can actually cross out. Remember, triangle and circle have to match the type. So let's go ahead and cross out the remaining odds. And so it looks like our two possibilities are 222 and 224. And I don't think there's a way to deduce that. It really does come down to testing criteria card F again. Now my gut feeling is that it's going to be 224, but only because it's rare to have a triple digit. But let's go ahead and retest. So it's going to be a quick third round. And I'm going to say 224. And let's see what happens. Let's test criteria card F again. Okay, yes, it does approve of there being a double. So let's go ahead and cross out this triple in our notes. And now we know definitively that it is a double. And let's go ahead and cross out the 4. And so, yeah, the solution, oops, I apologize, wrong one. I should cross out the 2 in circle. And so the solution seems to be 224. Okay, well, let's go verify. That 224 is in fact the solution. So 224. Okay, fantastic. Well, how do we do versus a Turing machine? Well, it is a 6 criteria card puzzle, but it took us 7 tests to come up with a solution. And let's see, we did B, D, E in the first round, D, E being correct. And then we did the remaining 3 criteria cards in the second round, A, C, E, with C being the only correct. And then we had to retest F in the third. So let's go ahead and type that up, B, D, E in the first. So B was incorrect. D and E were both correct. We tested the remaining. I believe A was incorrect, C was correct, and because F was incorrect, we had to retest it. There were 3 options, and then we got it right on the third round. Wow, we just tied it, so we just beat the Turing Machine. Ties will break our way. So yeah, we definitely got it. Well, I'm not sure if there were any, I'm sure there probably are better, maybe proposals, better selection of criteria cards to test. But, you know, a win's a win, I'll take it. But if you do have any ideas, how did you solve it? Did you choose a different set of criteria cards, and proposals, and beat the Turing Machine soundly, meaning that it wasn't just a tie? Please add your thoughts to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe. Well, until next time, have a great one.